Welcome back, dear children. I hope you all are safe and healthy. Today, let's begin with Chapter 9, Electrical Conductivity of Liquids. This slide gives us an overview of the chapter. By the end of this chapter, you will be able to define the electrical conductivity of materials, explain the electrical conductivity of liquids, explain the electrical conductivity of electrolyte, list the uses of LED in the tester, understand the chemical effect of electric current, explain about the electrolytic cell, define electroplating, and list the uses of electroplating. We have studied in lower classes that electric current passes through metals like copper, aluminium, etc. Not only metals, we also know that a few liquids like salt water are good conductors of electric current. Do you know why electric current passes in some metals and liquids only? Do you know why few liquids and materials do not allow electric current to pass through them? What is the reason behind passing and stopping the electric flow of current? Let's find out the answers to these questions in this chapter. Electrical conductivity of materials. In our daily life, sometimes we hear that our family members or neighbors experience electric shock when they switch on the fan or light with wet hands. Not only the switches, few other electrical appliances like water heater, iron boxes, ovens, etc. also cause electric shock if the wires or some parts of them are exposed. The reason might be the passage of electric current through these materials. Many of such materials which we use in our day-to-day activities are capable of conducting the electricity through them. Activity 1. Electrical conductivity of materials. Collect the required materials such as torch bulb or LED, a dry cell, piece of wooden sheet, 2 drawing pins, a safety pin and some connecting wires to carry out the activity. Take a dry cell and connect its positive terminal to one terminal of bulb with a wire. Now, take a new wire, connect its one end to another terminal of the bulb and the other end of the safety pin. Stick the safety pin on the wooden sheet with the drawing pin. Now, it acts as a key. Label the drawing pin as pin 1. Stick another drawing pin on the wooden sheet and label it as pin 2. Make sure that the distance between two pins should be less than the length of key. Take a wire and connect its one end to pin 2 and other end to the negative terminal of dry cell. Place the key on the pin 2 and observe whether the bulb glows or not. The bulb should not be in on position for longer time to avoid early discharge of the dry cell. Repeat the activity with different materials like pen, eraser, nail, matchstick, pencil, etc. by replacing the safety pin. Record all the changes you have noticed in a table. We observe that bulb glows when safety pin is placed on pin 2. Similarly, bulb glows when nail is used in place of safety pin and it does not glow when pen, eraser, stick, pencil are used in place of safety pin. From this activity, we have learned that few of the materials conduct the electric current through them while some do not conduct. The materials that allow the electric current to pass through them are called good conductors of electricity, whereas the materials that do not allow the electric current to pass through them are called as bad or poor conductors of electricity. We have learnt about solids. in which some are conducting and some others are non-conducting. Other than solids, the electrical conductivity of liquids is to be known. For example, getting shock when we on the fan with wet hands. This indicates that few liquids can conduct electricity. Activity 2. Collect the materials such as LED, dry cell, metal pins, rubber cap of injection bottle, distilled water and connecting wires on experimental lab. Take the rubber cap, insert 2 metal pins vertically. Make sure that the distance between 2 metal pins should be around 2 mm and the pins should not touch each other. Take a battery and a wire. Connect one end of wire to one metal pin and other end to battery negative terminal. Take another wire and connect its one end to the battery's positive terminal and other end to the LED's longer terminal, that is, the positive terminal. Now, take another wire and connect its one end to LED's shorter terminal, that is, the negative terminal, and other end to the remaining metal pin. The LED should not glow. Press the free ends of 2 metal pins so that they will come in contact with each other and the LED glows. This acts as a tester to check the conductivity of liquids. Pour some distilled water in the rubber cap till 2 metal pins are in contact with it. Now observe whether LED glows or not. Repeat the procedure with different liquids and tabulate the observations. When distilled water is used in the rubber cap, the LED does not glow. Similarly, when kerosene, sugar solution, honey are used, the LED does not glow. But when drinking water, lemon juice or vinegar are used, the LED glows. We have learned that few liquids like drinking water, lemon juice pass the electric current through them, whereas kerosene, sugar solution and honey does not pass the electric current through them. We also notice that LED glows in few cases and does not glow in others. When the liquid allows the current to pass through it, the circuit is complete and it is called a closed circuit and the LED glows. Then we can say that the liquid is a good conductor. When the liquid does not allow electric current, the circuit is incomplete and the LED does not glow. Then we can say that the liquid is a bad conductor. Dear children, with this we come to the end of our session 1. Please complete the assigned tasks. Read the lesson for better understanding of the concepts taught. With the help of an activity, explain the electrical conductivity of liquids. Why some material allows electric current to pass through them and why some do not. Explain. Thank you.